Hey, are we on? I feel people looking at me. Are people looking at me? Do you guys feel it? They just turned. Did you guys just turn us on? Say something over there. You're on. We're on. Oh, hello there. I didn't know you were there. I wish you people, when you come on, would make yourself known. Did you guys hear him come on? Scott?
No.
Are you there, Scott?
I didn't hear anyone.
I didn't hear anybody. They just sneak in here like they own the place, I guess.
Yeah. I could feel it though. I could
You
feel
can feel the vibes.
Yeah.
Okay. Hey, welcome to Midnight Science Club. I'm Jake. You hear the roar? The crowd's roaring out there. Hey, Jake! Oh man, he's here. Scott, you're gonna have to grow a beard. You don't look right. I mean,
I was gonna say, yeah.
You know what
I mean, Scott and I don't have beards.
Don't have beards either. Well, you're working on it. So, hey, I introduced you to. I'm Jake. I'm Wizard 4, and I've been Wizard for how many years, Scott? Since '93.
Oh yeah.
What is that? 29 years?
Yeah.
Something like that. Yeah. I'm Wizard 4. We'll talk about the Wizards later. But here we are at Faraday Studio, and we do this thing called Midnight Science Club. But I don't do all this by myself. I try to get the smartest people and the best science educators and the best scientists in the country to help me, because I know a little bit, but not everything. And so
when that doesn't work, you call me.
Well, no, and I tried to call all those people, and none of them answered. So I got these other two guys to help. What?
Jake, you're funny.
I know. That's Kenny Luna, and
That's
Kenny.
me.
I met Kenny at Discovery Channel.
Yep.
And this back in his tree hugger days. Were you a tree hugger?
I was a tree hugger. Yes.
Are you still hugging trees?
Yes.
Oh God! All the trees. Yeah, you saved a lot of trees, didn't you? I mean, you were a tree hugger.
I was a tree hugger.
Environmental activist.
I was. Yeah. Not so much the activist anymore. But I'm still teaching science and still enjoying myself, so that's good.
Well, that's good. No, but that was right at the very beginnings of the internet. I mean, that when people were doing things on the internet, it was kind of new, wasn't it? I mean,
it was very new. People were not using the internet to be an activist in the way that we were in large numbers.
Yeah, what you did back then was really it was like the pioneers going across the prairie, the internet prairie.
It really was.
You were one of the. So we're looking at this guy. Look at this. Look, Kenny. He was a pioneer in social media.
Yeah.
Yep. I was a pioneer. You're right.
Pioneer.
You're right.
What was the name of that family that with the pioneers that ate each other? They got lost in the past.
The Donner Party.
Yeah, the Donner Party. That's his last name, Kenny Donner. Yeah, we got eaten out there.
Kenny was the last one.
The last one out
Being
there.
a pioneer is a dangerous place.
So
you never know quite what's going to happen.
Social media pioneer, right?
Yeah.
Yeah. And then up there is Professor Scott Capes. Professor, yeah. He professed something once, I heard him. And I've known Scott for it's a half century.
Pretty close.
Yeah, pretty close. I met Scott at National Science Teacher Association conventions, and he was very active in that and local science teacher groups. And he's probably one of the best science teachers on the planet Earth.
So one of them answered.
Huh?
So one of the people you called.
One of the people, yeah, that's Scott Capes, right? And he cheats at cards. You can't watch him. Look at that face. It looks like an angel, right?
Careful. My camera won't go any wider as my head expands.
Is that what it is? Okay.
Yeah,
so I got those two guys with us tonight, and then there's this wizard in training. His name's Beckett. He's sitting right here. How old are you now, Beckett?
16.
The man turned 16. But you haven't got the beard going yet.
Not quite.
Got to work on the beard.
You got to work on the beard, man, and then the beer belly, and then the whole thing, and you'll be an official wizard. I'm telling you.
Yeah, it's likely.
But you're a basketball player.
Yeah.
Yeah. Well, I tell you what, Beckett is really intuitive. I mean, he gets it real fast. He gets it real fast. So you asked me something. We're kind of not killing time. I see people are signing on, which is kind of cool. Thank you very much. Oh, look at all these people watching. This is cool. Yeah. You had a question for me. What was it?
I did. Well, I was looking around the studio.
Oh, you're looking around the studio.
and I saw some really interesting things over here.
What is it? Oh, what is? Okay.
What is
What?
that shiny gold ball up there for? Somebody told me not to touch it.
Are you talking about up there above my
Yeah.
head?
Uh-huh.
Oh, can you see that shiny? You got a close up of that?
Shiny which one?
The shiny gold ball.
In between the green and the white ball.
Wow, that one there.
Yeah, get that. Get up here and get it close. It's up there on the. What thing? Scott, that's one of the most valuable things in the studio. You pick that out?
I did. It was pretty shiny. It caught my eye.
Huh?
It was pretty shiny. It caught my eye.
That belonged to Wizard 2, Hubert Allier at Princeton. Can you see what? I don't know what you're seeing on the internet. What are you seeing? Is that?
They can see it, yeah.
Yeah, you see that little gold ball? Yeah. What do you think that is? That's 1 pound of 24 karat gold
Oh my.
that Hubert Allier bought for $35 an ounce. Can you imagine that? $35 an ounce he paid for that back in 55 or something like that.
It's a good deal.
But it's been passed on. So I hang it up there just to drool over. I don't know what would a pound of gold sell for now.
Oh, a lot more than $35 or whatever it was.
Yeah, it's
30
true.
Do you remember when gold was $35 an ounce, Scott?
No, because I don't buy gold.
Well, I don't buy gold either.
Me either.
I was a high school teacher. You can't buy stuff like that as a high school teacher.
Well, I bought a high school ring. It had gold in it, back in '62 or whatever it was. Yeah, but that was Allier. There's a little card that went with this in the box. It said, purchased by Hubert Allier in I forgot what year it was, for $35 an ounce. So be careful with that. That's almost $500 worth of gold. And I don't know what it's worth now. Somebody will figure it out.
Wow.
I bet it's worth to see.
How much is it, Jake? How much is it weigh?
It's a
A
pound.
pound.
A pound. A pound of gold you have?
I have a pound of gold in a ball.
No, you don't think so?
Actually, I have 2 of them. I think they were going to be electrodes for gold plating or something. I don't know what it was, but it's stamped on a 24 karat gold. Pure gold. What is it announced today, Scott? You looking it
That
up?
can't be right.
What?
I mean, it's telling me here that the
Yeah.
spot price of gold is $4,771.
Yeah,
per
that's
ounce.
what I'm seeing too. And it's like, no, that can't be right.
Doesn't sound like that's right, but that's what they're saying.
$4,700 times 16. Oh,
You're doing pretty good.
that thing's worth 50 grand, isn't it?
Yeah.
Wow.
Well, we're going to the pawn shop tomorrow.
Okay.
Oh my gosh. So what else? That is a ball of gold, and I don't know. We'll have to get it down sometime. But it's kind of neat. I had it up there with the orbs,
Yeah.
No, I can't sell it. It belongs to the Faraday Foundation. It's a I don't know what you call it, an artifact of the
Yep.
thing, of the collection.
Yeah.
So close yet so far. There's another one. There were 2 of them. I was thinking about. I was going to start a Mr. T starter set. Get some gold chains for the wizard. Maybe
Yeah, that'd be
piercing
cool.
my ears. I'll just have them hanging from the lobes.
Yeah.
There,
Wow, that'd be outstanding.
$100,000 worth of gold hanging down there or something like that. I don't know. What else is on your list?
Just changed.
We're going down the list. We got to get to this topic, but he's got questions for us.
Well, what are those 4 tubes right there?
The 4 tubes
on the wall.
right there. Go up there and point.
These right here.
Those things.
Mm-hmm.
Those, pull one of those out. Those are the good pencils.
The best pencils.
We keep these. Oh yeah, that's. Ooh, look at that. Pull that out. That is a good pencil. Ooh, baby.
What makes it such a good pencil, Jake?
Oh, this is a Blackwing 502 or 602.
Only the best.
How is that? What is so special about that?
It holds a point, and it is the most pure graphite. And when you write with it, just here, right, just write a squiggle with it. Tell me what you feel.
It's very, very smooth.
You don't feel anything, do you?
Yeah.
I mean, it's like writing on air. Yeah, Blackwing pencils are the best ever, and they got a great big fat eraser on there.
Oh, yeah.
Oh, look at it. The eraser comes
at it.
out, and you can replace them.
Oh.
as if you'd ever make mistakes. This thing. So black wings. So we keep those up there because I'm into graphite writing. I actually do write things. Scott, I've got paper and pencils. These graphite writing sticks. These are implements used by people, born 75 years ago. What else did you
No
see
one
up there?
uses those anymore, Jake.
Huh? I know what it is for. It's for.
My kids in my classes don't know what a pencil looks like. Actually, they borrow them from me constantly, but they don't use them.
They don't use them for anything. See, you want
Yeah,
look at this. I mean, I want to tell you how trendy I am. Are you ready for this?
yes,
What is that?
Oh.
big chill tablet.
Yeah, your big chief
Man.
tablet.
1951. Here I'm in school. This is what we learned to write on.
Wow.
A big chief tablet. Look how wide the lines are. And let's say you practice A, B, C.
With your sweet pencil.
Huh? So you have a big chief tablet and a black wing pencil. You're ready to take the world on, man. I'm telling you. And you can
Wow.
still buy big chief tablets. They're kind of cool.
Can you really?
Yes, you can.
Wow.
And they're really good. They're smooth. They're just right for kids to write on. Yeah.
There's probably an app that you can put on your iPad.
I'm sure.
It'll make
I'm
it
sure.
look like a
I'm
big
sure
chief
now
tablet.
this is probably politically incorrect, right? I have no idea. So if I offended anybody with having a big chief tablet, I'm not really that sorry, but I always say so. So I don't want to hurt anybody's feelings at all. I don't know. Some people have tablets named after them. See, what would be named after me? A can of lard or something like that, or a bag of hot air. Wizard airbags or something. So, did you see something else I've got to explain to you?
Well, right over by those pencils, I saw a pair of really nice looking scissors.
Oh my gosh, those are the good scissors. Now, when you grew up, I don't know, did your mother or your grandmother have the good scissors that you're not allowed
yeah.
to use? You remember good scissors?
Yeah.
Don't you use those good scissors?
Oh no, not
Kenny,
unless
that-
you were cutting thread.
Yeah. Kenny, did you
Even
have
then,
that? Did
Mom
you have
had
a
to
grandmother, an aunt, or a
Oh,
mother?
my mother, I remember having the pinking shears.
Oh yeah.
Those are the special scissors.
Mhm.
Yeah, you don't
she
touch
did-
those. Don't go.
Yeah,
You don't go
she-
cut those and make stuff with them. She go.
She did a lot of sewing, a lot of hand making.
Oh yeah.
That kind of thing.
See, I'll let Beckett experience what good scissors are like.
Okay.
These are called scissors. Now I swear to goodness, I was at a Montessori school in Morristown, New Jersey, and I had some scissors and I cut out some paper dolls. You know how you used to cut them out and then pull a string of them out in front of a group of fourth graders, and they went nuts. How did you figure that out? And I tried to get them to cut out paper. They could not operate. They never operated scissors. Where do kids operate scissors nowadays? Very rarely. But just feel these scissors. Here it comes. Ready for this?
Yes.
What, yeah. You notice anything?
And there's no resistance hardly.
No resistance. Those are good scissors. Now here we go. Cut the paper. Here
Okay.
it comes. Here we go.
Oh boy. That's a nice cut.
That is smooth. Woo! So it's like cutting through a putty. Oh yeah. I wonder if I could just look at this.
All the way.
I don't even need it. I just get started. Look at that.
Wow.
Those are good scissors, man. Every scientist worth his beans has a good pair of scissors. Well, you have to keep them out of the way. I don't know where we got these.
These are not good scissors. These are from
good
the dollar
scissors.
store.
Yeah, that's what I'm saying. Well, of course, we were the plastic handled ones with the rounded
Oh
tip.
yeah.
That's kind of an insult, you know.
They came in a set.
You get 50 of those for $1.
Yeah, 50 of those for $1. These were very expensive scissors, but they're so nice.
Yeah.
So we keep them hanging up there in the studio. That's from the Wizard Club, the good scissors.
Our good scissors, Mom's good scissors are still in her sewing box.
Yeah, she won't let you touch them.
Oh yeah, they don't ever come out.
And I don't know why. I don't know what it was. I guess we would dull them somehow or something.
Oh yeah. Cut something stupid like
Yeah,
paper.
yeah,
More
no, I
like
know.
ourselves.
Yeah.
Well, let's see. One other thing. What else you got on there?
Well, I noticed this over here earlier.
We got 3 or 4 more of these. Just waiting for people to sign on. Yeah. What else you got? What did you find in the studio?
I saw this over here. Wasn't quite sure what this was for. What do you do with this?
Now, how old are you?
16.
He's 16. He's a smart man. Wants to know what this is. Kenny, you ever seen one?
Me?
Yeah.
I've never held one, but I've seen them.
Oh yeah.
Scott, have you ever held one?
Oh yeah. Yeah. I just don't own one.
Really?
Yeah. I know. It's shocking the things I don't own.
I don't know. This is a nice one. We've got a nice blade on it too.
Yeah.
Ooh, that's sharp.
It looks sharp.
It is really sharp. That's a cleaver,
Little cut
right?
paper.
That's cleaver. That's for, I guess, back when you're butchering meat and stuff, you want to get a
Oh,
good
yeah.
whack on something, or want to split a
Yeah.
watermelon open in one whack or something like that. It's a meat cleaver. I don't know. It's amazing what psychological, emotional thing happens when you pick something like this up, and it happens with lab equipment with me all the time. You get this in your hand and you go, I feel different. Does that make sense?
Too many scary movies.
Oh yeah, I never thought about that.
Yeah.
That's a meat cleaver.
Yeah.
Yeah, whack, chopping up pork chops or whatever. I don't know. I've never used one for its intended purpose. You know, but we do chop things with it.
Mm-hmm.
It's just a real heavy knife blade.
Yeah.
But it looks cool, doesn't it?
Oh yeah.
It's kind of like me. Why do they keep me around? I look cool. I got the cleaver. I bet they could take a finger off.
I'm sure.
Oh,
Yeah, I'm sure it could. It might take
Yeah.
off. I might take off more than that. It might take off your hand.
Yeah.
Yeah. And
Couple
by the
good
way,
whacks,
well,
I
that's
could see
in the
this
chat,
going
if everybody watching, if you want to see something when you studio, because the studio goes on forever. You say, hey, what was that blue thing over there or something? Let us know. It'd be kind of cool. Hello, Wizard. Hey, Muscle, you're back. Man, he's back. That's Muscle Car Pat. Now, see, I tried he's been around several times. I go, who's Mucal Carpet? I thought he was some sort of carpet. Now it's Muscle Car Pat. That's cool. I'm glad he's back. And Cortland's back. That's great. This is cool. What's the other thing you found?
I have no idea what this is, but it was over there by the cleaver.
Oh, come
Decided to
on.
bring it over here.
Really? You don't know what that is?
I have no idea what this is.
God.
I don't know what it is either, Jay.
Oh my gosh. Give me that thing.
What is it?
What is that? I mean, this is from the 60s, man. Oh, geez.
I'm not from the 60s.
60s.
You're from like the 2010s.
Exactly.
No, 2010, man. That's back in the thing. It's got a handle, right?
Yeah.
And it's just a regular little piece of pipe, and it's got this piece of aluminum,
Mm-hmm.
like a channel, right?
Yeah.
Now you imagine a bunch of people in my generation, back when they were teenagers or whatever, with long hair and beads,
Oh.
kind of hippie-ish, right? And what did we do in the park on the weekends? We'd be flipping something,
Going frisbee.
frisbees.
Frisbee, yeah.
You remember we were the frisbee generation. Those guys would dance, and we had dogs trained to jump at the frisbees and everything.
And hacky sacks too.
Hacky sacks,
Yeah,
sacks and frisbees.
I haven't done a hacky sack in a long time. I do frisbees with my kids though. They're fun.
Well, frisbee tossers were good. They could toss things and throw things at
Is that
each
what
other.
that is, Jay? Is that a frisbee
It's
tosser?
kind of a frisbee, kind of like thing. But suppose the picnic table was way over there, 30 yards away,
Right.
and you said you wanted a snack. How would you get the snack from the picnic table over to you? And you're a frisbee tosser.
Depends on the shape of the snack.
Yeah. He put a cookie in here, all the way across the playground there, man. This is well, I suppose you could put an Oreo cookie in here, maybe half an Oreo, but a Ritz cracker, it flies like a son of a gun.
Does it really?
Oh man, it's just like a flying, it's a Ritz
Wow.
cracker flipper. Doggone it. We'll get some Ritz. I mean, what do you got, man? Do you have one? Scott's laughing at me. He's smirking.
Oh.
He knows
I
I'm
got
losing.
a whole
I know-
box of Ritz crackers. I don't have a thrower like that.
I was gonna say that's a professional device. I don't own
Yeah.
one.
Well, you know what you're getting for Christmas.
A cookie
We're
store.
gonna get some Wizards 4. Ritz. Oh, here we go.
You can have them as merch, Jake. You can sell them as merch.
Branded
I'm a
Oreo
merch
thrower.
man. We're gonna do the merch thing.
So a whole Oreo.
Oh,
Won't quite
this
fit.
won't
We can
fit.
do
We'll
half
take
an
half.
Oreo.
Yeah. Okay. So this would be good for. Yeah, get all the icing off of there. Oh yeah, this is gonna be great.
There we go.
Yeah, Ritz cracker. Oh yeah, it rolls. You see that roll?
Yeah.
It just
It's
rolls
gotta
right.
roll.
Oh yeah, you know. Now how am I going to demonstrate this? Oh dear.
Not like that.
I'll flip it towards the wall over here. Ready? 3, 2, 1. Hey, oh, I almost took you out, didn't I?
This close.
That close? It did shatter?
There's a couple of good sized pieces.
Yeah, it kind of shattered on impact, but that's what it's for.
So
you
what's
can
it
put that
really
back.
for, Jake?
I have no idea what we probably did. Mr. Wizard or somebody did an episode, science episode with that. I don't know what it would be.
Yeah.
Some with the rings of Saturn or something. I don't know what it would have been. Centrifugal force or
Yeah.
Oreo rings of Saturn.
the Oreo, flying cookies. Is there anything else? Can we move on?
Well, I noticed that big giant box up there. I wasn't quite sure what that was. One with the green paper on the front.
Well, that my boy is. Get a picture of that up there. That was a TV from 1953. A Philco Predicta. That green paper is just our Jacob, the technical guy, put that on there for camera purposes. But that still works. We'll get that thing fired up one of these days. That's what I watched TV on. That's Mr. Wizard was on there in 1951.
Wow.
So that's a Philco Predicta television set, black and white.
Still works too.
Still works, and then guess what? It gets 13 channels
Wow.
14.
in a row. I'm telling you, black and white. And it probably only cost 2 months' pay back then. Probably a month's pay back then. I don't know. What it was.
Well, yeah, something.
Yeah, something like that.
That
One
was the
last
hot-
thing.
That was
Oh,
the
yeah.
hot new thing.
That wood thing there.
Yeah.
Yeah,
What is?
okay, that one right there.
We got
Okay,
some-
that's that. See, finally you got something that we're talking about today. I'm gonna eat that cookie.
Yeah, there's some Oreo dust on here.
Okay. No.
What on earth is that?
I have no idea.
Okay.
Looks
That looks
there's
like a
another-
chopper.
There's like another cleaver on there.
Yeah, I was gonna
Everybody what
say.
it is.
Looks like we got a little handle action going
Yeah, I got a
on.
handle action going.
Maybe a slot you can put something in to
Somebody's
hit with
finger,
the handle.
yeah.
Yeah, finger.
Put your
Boom,
finger in there and
boom,
break that
boom.
bone. This
Yeah.
is a knuckle buster. This comes in handy all the time. It's just made out of wood. All right. And it comes down. It looks like you'd lay a hot dog in there or something. And slides down. And I got this out because this is what this is about the topic we're gonna talk about today. Uses this device all the time. Now, why would a 7th grade science teacher have this in their classroom, in the back room? I wouldn't let kids mess with it; they'd break their fingers, you know. Why would a science teacher use this for? A lot, especially if they're dealing with basic electricity. Very basic magnetism and electricity. What would that be for?
Can you cut wire with it, Jake?
You might be able to cut wire if it's soft wire, yeah.
There's no blade on there. I don't
There's
know
no
if you can
blade
tell.
on
It's
there,
just a
no.
piece of wood.
Yeah,
Gotcha.
just a piece of wood on wood.
Well, I mean, it could be used as a model for a switch.
Yeah, that's great. It's good. Yeah, a model for a switch.
Somebody in the chat got it right, I think.
What? Oh, Blazer, it's for separating magnets. You've been around. Oh, Blazer, whoever you are, Blazer.
Nailed it.
He nailed it right on the head,
Oh.
or she, or it, or what am I supposed to say? Person. That person nailed it. Are you a robot, Blazer? No, I guess not. Anyway, yeah, it's you get some of these little rare earth magnets, you can't get them apart easy without breaking your fingernails or something. But you put it in here, and you can slice them apart like that. Isn't that sweet?
I never heard of such a thing, Jake.
Oh, you would unless you're working with lots of magnets,
Right.
you know. Oh, that went back on. I didn't get that one all the way down. There we go.
We do magnetism, but I've never had to do that.
Well, when we're doing this stuff, and you buy these magnets, they're expensive, and then you end up breaking them. They're kind of brittle, you know, trying to get them apart if you drop them and stuff. So it's one of those exclusive things that only the blazers and elegant science teachers like Jake have.
Yeah.
I guess
I was gonna say I
Blazers have
didn't
a lot
have
of
one, but
experience
I had to
playing
pull magnets apart all the time.
Yeah.
Played
We
with a
didn't
lot
have
of
that at the
magnets.
university.
Really?
My gosh.
And you didn't know this existed?
No, I did not.
Well, see, there you go. Well, today we were going to, that's cool, isn't it?
Yeah.
You just stand here, just like, here, take a picture. Wizard and wit with magnet separator. You never know. You get to figure that out. There it is. Thank you. Thank you for sharing that, Blazer. Oh, those go with that? Yeah, I guess those go with there. I don't use that often, but when I need it, it's just perfect. You know, because it doing stuff with magnets, you want to get them apart, and we got some stinker magnets here that you can't get apart by pulling. You have to really cuss at them and twist and fork or something like that. So anyway, what we thought we'd do tonight, and you folks who are signed in with us, the purpose of this stream is we put out a lot of science videos to our 2.2 million followers and all the viewership we get sometime. And I like to not just to rely on my old head by itself. It's even though it is a magnificent brain, I must say. I know, what can I say? I get a big head, don't I? Yeah. But it's good to bounce ideas off of each other. I think it's something in my religion says wise men enjoy sharpening, steel on steel, right? You enjoy sharpening your wit, steel on steel, that we sharpen each other. So I'm going to get Blazer 5154 and Muscle Car Pat. And Kim Arnold. No, you can go right on. You just keep right on going. There's Kim. Did they let you out on parole? This is good to see you, buddy. This is wonderful. We want to share ideas together on basic magnetism and electric current. We had a person ask us the other day, I don't know anything about electricity and magnetism, and I'm supposed to teach it, and I just feel so uncomfortable even starting because I don't know where to start.
Yeah.
You know what I mean?
Mm-hmm.
And it is. So what part? Electronics and electricity is very complex. People study it for a long time. So we're going to go through some of the very, very basic. Imagine you don't know anything about magnetism or electric current at all. And what key points should a young person know? And of course, our target audience is 10 to 14 of all of our efforts. So how long ago was it you were, Kenny, 10 to 14? Is that half century ago, third of a century ago?
Well,
Yeah.
50. So what is that? 36 years ago?
Yeah, third of a century ago.
Yeah.
Yeah. And
It was
Scott,
a
I'm not even
while.
going to embarrass you. I mean, that'd be embarrassing.
Half a century.
Half a century ago, yes. I'm bouncing off 3/4, so it's like, yuck. What are you going to do?
It's only been 2 years for me.
Only been 2. Get out of here, punk you. Miserable. So what's the first thing? Okay. Where is that piece of rock? Do you see an ugly? Where is that piece of lodestone at? Where did we put that? We got to find the lodestone. Here comes the lodestone. I don't know where to start with magnetism. Where would you guys start? First thing you want to.
I would start with a lodestone. I think that's a great place to start.
Yeah. Do we have any iron filings? Oh, look at this. I want you to look at this, buddy. Thank you. What do you see there?
We got a pretty good sized rock with, looks like some either stains or like chippings coming off
Yeah,
it or
chippings.
marks, something like that.
Mm-hmm.
Pretty
you know,
heavy.
And you see that kind of, I don't know if it's dust or what is that? It's black with what? What color is that?
Like brown.
Brown.
Or like some yellowish too.
Yeah, yellowish and kind of reddish brown maybe.
Mm-hmm.
Yeah. Here we've got a stone that, this, I forgot who wrote it. An Englishman, it wasn't Isaac Newton, said, what were the greatest inventions that changed the world more than anything else? Who was it? He wrote it in about 1650 or something. I forgot what it was. The greatest things that man came up with that were very powerful things. And one of them was a compass.
Right.
Just thinking. Another one was printing.
Yeah.
Another one was gunpowder. Do you remember this saying? You know, it's some guy.
There's a saying about it?
What about the wheel?
Yeah, wheel. Yeah, you would always say inventing the wheel, right, was the big thing, right? Inventing the wheel. Who invented the wheel? But said the great in recent history at that time, it was the printing press, was just incredibly powerful. Gunpowder was incredibly powerful, and magnet, a compass. And just think what the world would not be like if we didn't have those original compasses. You know, the explorers and all that
Columbus
stuff.
might never have sailed the ocean.
Oh yeah, you wouldn't know. You just wouldn't know.
But wait, Jake, how in the world does a compass work?
Oh, he's being smart. Like, you see that? He tries to put on that sweet but ignorant face. Hi, me. Well, you know, I have never gotten a good answer. Because, you know, they always say with science, you say something, you've got 10 more questions, right? Right. Somebody will explain something to you, and then you'll go, well, but what about? Well, somebody, and I don't know who it was, I think it was Francois Magneto was his name. I have no idea who did that. Discovered that this particular bit of iron, because you know the Earth is made mostly of what?
A lot of iron.
A lot of iron. Matter of fact, I'm sitting here in this chair, and beneath me, I go down about 4,000 miles to the center, about 4,000 miles down. It's a big molten ball of liquid lead and nickel, and then a bunch of stuff around it, the mantle, the core and the mantle. I guess there's a couple of layers to the core, yeah. But mostly it's this, or something like this.
It's 4,000 miles to the center of the Earth, Jake?
Yeah, it's 8,000 miles across, right?
Oh, I didn't realize that. That's so fascinating.
And we know, it's amazing when you figure that we are on a crust that's a few miles thick, right?
Yep.
It's like icing on a cake or something like that. And below us is all that hot fire. Here we are, these little creatures living on a big ball.
Yep.
On the crust.
Yeah.
They usually it's the analogy. It's like the skin of an apple is where we
That's
are.
right. That's right. Skin of an apple.
Yeah.
See,
It's
see,
that.
That's why.
That's
Did
why
you
we
hear
have
that?
him here.
Did you hear that?
Yes.
That's why you're here. That's one for Scott, right there.
Scoreboard.
Wow, that's good. The skin. I'd forgotten about that. The skin of the apple. That was the thing. Yeah, absolutely. Well, this is called lodestone. It's iron, and you look at that orangey brown. That's iron oxide. That's kind of a giveaway sometimes that it's iron, right? And for some reason, this has a magnetic quality. I've got some iron filings. I don't know. I think we should sprinkle some of these iron filings on here.
Let's do it.
Not directly on it.
I was going to say,
You'll
don't do
never
that.
get them off.
Well, look, you see the two science teachers? They're sitting there going, what is it?
Yeah, I wouldn't. Well, Jake, it's your
I put
show.
a piece
but
of paper over it.
I would do something. Or put saran wrap or something.
Okay. See, these guys are good. Did you see them? They're both set up. Don't put that on there.
You could both have a half point.
Don't put that on there. So to
That's
the first
that's because we don't have all kinds of assistants to pick all that stuff back off.
I was going to say, you can tell we're both teachers because we've seen this done a million times. And we tried to pick the iron filings off of a magnet another million times.
That's right.
And, kids inevitably do it, which drives me nuts.
Oh, yeah, dry. And you got to pick all that stuff on.
And they just walk out of the classroom not even aware of the hassle.
All the mess they made.
Yes,
Yeah.
exactly.
Do you want to sprinkle that on there?
Sure, I'll be sure to be careful.
Well, you just don't mess up because everybody's watching you.
I know.
That's it then.
How much you want on there?
Well, just keep going. You can shake it. Get a little more violent with it. Pretend it's like it's one of your buddies. Okay, they are kind of arranging themselves in a certain pattern.
Yeah,
aren't
they are.
There you go.
There you go.
Look at that. I'll keep on going. Yeah. Do you see some lines forming there?
I do.
Now the question is, of course, that's good enough right now. How do those little iron filings know to lay in those lines? Who's telling them to move there?
Lodestone.
Yeah, but how's a rock communicating with bits of steel? I mean, how? Look at that. I'm vibrating this to help it move.
Mm-hmm.
Isn't that amazing? Here I'm 70, 90, 100 years old, whatever I am, and I still get a kick out of that, seeing how that works.
Yeah.
Yeah. Yeah.
That's a good idea. Blazer just said that the duct tape is a good idea to get filings off a magnet, and if you do mess up and get them on there.
Oh, is that
Man,
yeah,
Blazer, you've been around.
Then you can't get it off the duct tape.
Well, that's all right. Well, at least you have a clean thing, but that's good. Write that down. That's one for Blazer.
Yeah, that's a
That's
point
one
for
Blazer. It's 1-to-1 going on there. I'm glad you're sharing that. So actually, we're seeing something, right? And we're seeing the magnetic field. Jacob, do you have that picture?
Yeah.
A few years ago, and we're going to go there again. We got to go to the Royal Institution in Great Britain, and we got to go into Faraday's lab, and I just cried like a baby. They showed us the images that he made just like this. The first pictures that we know that was recorded by a scientist anyway. Are those things up on the screen?
Yeah.
You can see.
Can you see those? Those are Faraday's images. That the Royal Institution shared those. Look at that. Does that look like anything like what we got?
Oh,
Does.
A little bit, yeah.
Yeah.
It looks like a lot like the top center one, in my opinion.
Yeah. Yeah.
Mhm.
Those are Faraday's images of magnetism. Now they didn't know about fields. They did not know about this field around a magnet, and much less what caused it. You know, and some people would.
This
thought
was
Faraday-
when, Jake?
Huh?
When was this in history? What year was this? Do you
Oh,
think?
Faraday's been 1820, 20-ish, something like that. I think 1817, 1820.
When you think about the flash of history, that all the stuff that we have learned in the last 100, 200 years.
Yeah.
You know, I mean, it took 5 million years of human evolution to get here, and it's only in the last 100, 200 years that this stuff has been figured out. It's pretty wild.
Oh, it is pretty wild. And you figure out how Faraday did it. I mean, just by. I'm going to dump that out of there. Now that's a lodestone, and that's how they made the first compasses. They would take some softer metal and rub it on there and get it magnetized. You know, I don't know if do you think when we explain to people we should talk about domains and how the atoms line themselves up when you make a magnet? Do you think that's?
Yeah, I would.
I think you have to.
You think
Yeah.
anybody go into that?
It's actually made up of little tiny magnets.
Yeah, they're all
Because
arranged.
magnetized, they all start to line up with each other.
Yeah, yeah, I agree.
And if you do the geology, because you're talking about lodestone, it's technically the mineral magnetite,
Magnetite, right?
and it has iron always has those little tiny domains that are like little tiny magnets inside. When the lodestone was formed in the Earth's magnetic field, it was molten, and as it cooled off, those little tiny magnets were able to line up enough that it created a bigger magnetic field.
That's
And
right.
you can do this, like Jake was saying, you can line those up in any kind of magnetic material.
But it was liquefied so the atoms could move and be
Right.
aligned, right?
And then as it cooled off, they stayed lined up to make a permanent
right.
magnet.
That's
Yeah.
got to be another point for Scott.
He's trying to get more points.
We're
It's
not-
that
we're not
earth
gonna-
science education.
We're not going to give it
stuff
to
that
him.
I was gonna
Yeah, we're
say
getting
he's got
points.
the earth science down.
So we got when we present this, then in the next 2 or 3 weeks we'll be shooting the videos on this. We need to mention domains and get a picture of the domains.
Yeah.
Then. Okay, that's what we'll do. So what would be the next step? Now, see, you know, the thing that I had, do we have the little needles? Do we have some needles? Now bring those needles over here, would you? I want to see if this will work, because we were going to try to I think I
You're
put
trying to
those in the
magnetize it?
trash can
Trash
down. Yeah, right down by your feet down there.
Yeah.
Yeah. Where is that?
See, we wouldn't have done that. We
We're
would
going
have
to try to make an old compass
Okay.
that floats. Some water. You have all that stuff put together. These guys are good. What do you think the first compass was like?
Well, I'm guessing it was a lodestone just hanging on a string.
I was gonna say that's almost something worth trying tonight, actually.
Yeah, we're going to try that tonight. Check this out. Okay. Oh, you got that over there. Here, set that over there. We'll do this. I don't know if this will work or not. First time. Did we magnetize this needle? Maybe. Well, I've got a needle floating on a bottle cap. Now it's stuck to my thumb. What the heck's going
There we go.
on here?
There we go.
There's a needle floating in that water. Can you see what it's doing? I'm not touching that thing.
Yeah.
We magnetized that needle a little bit. It's being pulled by the surface tension of the water, but it's trying. It's trying.
I was gonna say it hasn't quite gotten it yet.
Quite got it's pointing in one direction. If you look up above us in the studio, we've got north, south, east, and west pointed at. North is off over that way.
Yeah.
You see the N up there on the deal up there.
Yeah.
I don't know what do you call that north, south, east, west thing? I don't know what.
Cardinal directions.
Yeah, there used to be a fancy name for it. I don't know what it is.
I think he means for the
Oh, the weather. Yeah.
weather vane.
The weather vane, the 4-letter thing there. So we need to. I don't know. I'm going to try it with a lodestone. I don't know if we're up in this. What do you think, Scott? That's going to get magnetized.
Oh yeah, it
enough?
should.
What am
Now
I
make
doing?
sure your lodestone's out of the way after you're done.
Yeah.
And there's no metal in the desk, is there?
So what am I doing right now?
You're lining up those domains in the needle.
The domains, man. It has domains.
Little tiny magnets in there.
Mm-hmm.
And those little domains that are in there are just clusters of iron atoms, aren't they?
Yep.
Yeah. Now you know I'm not going back and forth. I'm going in one
Right.
direction.
Yeah, one direction. Yep.
And
It's
if you
kind of
don't,
like combing.
yeah,
Like if you're combing hair.
yeah.
Tell you a
Now,
funny
you remember
story,
what else
Jake.
you can do to? Do you remember what else you can do to a needle or a nail to magnetize it? In an emergency.
I
What if you
know.
don't have any lodestone or magnetite?
You need another magnet. You need another magnet.
Yeah, well, what if you don't have another magnet around?
Well, then you're sunk.
Well, see, there is another
Maybe.
magnet around. There is another magnet around. We're standing on it,
Yeah.
right?
I don't
But
I
how
don't
would
know if you actually
how
hit it
would
with a hammer. I've never actually tried that.
Well, you can demagnetize it by hitting it with a hammer. I know
But
that.
if you hit it hard enough and let it set, I don't know if it would start to line up or not.
I
if you
think you
heated
can,
it
I think
up-
you can put a nail on there if you hold it in the right direction all the time. Point the nail.
Oh yeah.
I think north is. It will magnetize that nail
Oh.
a little
Explain
bit.
that, Jake. Explain that to me again. If
No,
you
I've
do
done it.
what?
Maybe we'll do it if we have time. I'll get an anvil up here and we'll put a nail on it. And we'll beat on it if we and beat it, smack it hard. There's enough heat energy, mechanical equivalent of heat, to warm up that nail, and it will magnetize slightly.
Wow, that's so cool.
Just from the Earth's magnetic field.
Yeah, yes, this lined up because the Earth's magnetic field will help it line up a little bit. Oh my gosh.
Oh, stayed on. We're good. We're good.
We're good. We're good. We're good. We're good. Okay. Is it going to point north?
Should.
It's kind of pointing north.
Well, it depends which end we're talking about.
Oh, is this a north and south magnet deal?
That's pretty close.
Well, anyway, this is the thing we're going to do down the road is, let's see, Blazer said an old MacGyver episode showed striking an iron bar against a fire hydrant to magnetize it. Ah, Blazer's been around.
That would have been a big compass.
Hey, Blazer, you don't. I wonder who the science advisor was for MacGyver. Do you
Who
remember?
could that have been?
I don't know.
I have
remember that
no
episode?
idea, Jake.
He must have been some good-looking stud muffin. You know, see, why did we get paid? Every time the MacGyver folks called us, we got paid. I think it was $50 a phone call or something like that, and then we got a fee. And they would call every once in a while to Wizard Studio. When I worked for Mr. Wizard, he was the science advisor in MacGyver for a while when they first started. And what was the one they wanted to do so bad? Oh, MacGyver is in a fist fight, right? In a restaurant. And they wanted to push, they wanted it to look like the guy was just about to push his face down onto a hot griddle. You know, and then he would pull some stunt. So just imagine some big guy wrestling MacGyver in a restaurant kitchen, and he's got him, and he's getting him down, he's getting his head right down next to that grill. And they wanted to show how hot that grill was, right? And they were shooting it with a camera that they rented, I don't know, Panavision or whatever it was. And they wouldn't let them put the camera over the hot stove because it's bad for the camera. But what they wanted to take a picture of was a drop of sweat dripping off of MacGyver's forehead or nose and hitting that griddle and going, psst. So they called me up, called Mr. Wizard, and I just happened to answer the phone. And they said, how do we do that? What could we do to block the heat from the stove so it wouldn't hurt the cameras, right? And the film or whatever. So we thought about it for a long time. I said, why do you want to do that? Well, because we want to see some sweat drip off of Richard's nose or his forehead or whatever, and have it go hiss on the griddle. So we thought about it for about an hour, and then we realized, well, instead of trying to block the heat, just turn the stove off and go down to the welding store and get some liquid nitrogen. And from off camera, and from off camera, just dribble a little drop of liquid nitrogen, go right past his nose, hit that ground, go psst, like that. That's the best thing.
That is hysterical. And what a great idea. Who came up with it? Jake, did you come up with that or did Wizard?
I did. I came up with that, and you know, I didn't get
That's a point for Jake.
That was 1 point for me.
That is a point for Jake.
That was one time for a point. I was thinking because I knew that hissing noise because you know we used to play with liquid nitrogen a lot anyway. How do we get off on that? I don't know.
Oh,
we got to move on. Well, anyway, okay, we'll get
somebody
this.
said they saw it on MacGyver.
Yeah, I saw it on MacGyver.
Yeah.
We'll get this thing. We'll get a needle when we do this. We'll do it better. You know.
Okay.
But the idea is that we're going to make a compass. That would be
The
next
needle ought to
step.
just float on the water because of surface tension. You don't need the bottle cap.
Yeah, we could do that. You know, if I get a fork and lower it on there.
Yeah.
Okay, we'll move on. Let's see, what's the next thing on here that we're going to do? Emergency compass. Oh, I know. Why don't you get rid of that and bring that other magnet back?
Get rid of this one.
Yeah, and bring that other pan. Where did we put that pan? Yeah, bring that pan. Is that mega magnet here? We got to start messing around with the good
Muscle
magnets.
car commented again.
Yeah, you get that. You take that out of there. Yeah, you just take that whole pan. Yeah, now we're talking. I want to see some. Don't spill that on me. We got some neat stuff to show you guys this week, by the way. I'm so glad that Blazer signed on it. You guys are reliable. Thanks for signing back on. I got some neat stuff to show you. Do we have a really strong magnet?
Looks like it.
Yeah, in that box, man.
Oh shoot.
Is that good?
Feels
Now
good.
we're talking serious Oh geez, we're talking serious magnet here, right?
Yeah.
Okay. Oh gosh, get that off. Can you get that off there?
Let's see.
Well, thank you. You're strong. Now, hand me that cardboard box. It's a strong magnet. You guys ever have one like that, this size?
Oh, yeah.
School? Oh yeah.
Yeah, I've had them.
Got a needle
Yeah.
on there.
Oh, there's a needle in there. There's a needle.
Set the metal plate under the magnet.
Oh.
It'll keep it, it'll rise it up a little bit.
Put the metal plate under it. Okay, there we go. Ooh. Is that good?
It's good.
No, and hand me that part right there.
This one?
Yeah. Yeah, this is good. We got a little tray. Catch the iron filings. So are you with me so far? Got the very powerful horseshoe magnet. There you go. Now, when you guys taught this, what did you say about when we put the iron filings on the magnet? Can you remember saying anything particular, kids?
Well, we just talk about the domains, how everything lines up, how you see the field, the lines of the lines of force, that kind of stuff.
Yeah.
Well, I was thinking, I look at this thing and I'm playing with it and I'm going, well, there's not much there. I put my hand down in there and it doesn't mess up my language or anything. I don't feel anything.
Right.
Do you feel anything?
No.
I don't feel anything. So I don't know how you'd know anything was there.
Right.
So put that on there.
You want me to put
Yeah, put that on there. Put that on there. Let's see what the iron filing is.
I guess the thing to know or to wonder is this going to get the same pattern as the lodestone did?
Oh, let's see. Okay, remember the lodestone. Remember the pictures we saw.
Yeah, I was gonna say, do they match up with what Faraday saw?
Here, pop that lid off there. We're gonna be here for days. Can you get that off there? Now we're talking.
Uh-oh.
Yeah, now we're talking. Give me some of those too. Dump a bunch in my hand. Oh, this is kind of cool. Yeehaw. Oh. Yes, sir. Yeah, you got it. Yeah, spring a bunch more on.
Somebody else commented.
Oh, what is it? This should be Muscle Man goes. This should be more organized. Yeah, you're right. An old CRT. Oh yes. Take this in front of an old TV set, an old monitor, and see how it distorts the pattern. Yeah. I like to do this. It's like. It's the hair on the.
There we go.
Yeah, it's the hair on her legs was dancing around as a thing with the stuff. Yeah, that's kind of cool looking, isn't it?
That is
Flashbacks of the old Woolly Willy.
Woolly Willy.
Oh, there. I couldn't
Gotta be
remember what he was called.
Woolly Willy.
Yeah,
It's the thing with the mustache,
Yeah.
right? Yeah.
Oh,
I've
not
seen
a
those.
color TV. What is it, Kim?
No.
Kim suggests not a color TV.
One above
Oh,
that.
that's right. You can mess up a color TV, right?
Oh, easily.
I guess we did it at the Cosmosphere, Omnisphere. We had it. It was a black and white TV, wasn't it? Yeah. Move hair on a man's face. Yeah. Yeah, I guess we could do that. Put a picture on there and have the eyebrows say, "Hey, honey, how you doing there?" Kind of wink at her.
Yeah.
We can go to the dollar store and buy one.
Yeah.
I think
they
it's
do.
And by what, Scott?
The Woolly Willy. It's a card that has a man's face, a little guy's face on it.
And you can
Yeah,
drag the
pour
shaving
in
trim.
some iron filings, and it's got a plastic cover over it. They give you a little magnetic wand, and you can drag the magnets around, or drag the iron filings around to make him have hair and stuff.
That's cool.
That is
Okay,
kinda cool.
the neat thing about what you're doing now is this is showing that it's actually that field is in 3 dimensions because you can see stuff sticking up out of the top.
Yeah. And then the question, of course, is, what is that field made of? I mean, that's what we want to get them to think about the field.
Yeah.
Say a field. What are you talking about, field? What do you know about? Do you know anything about fields?
Not a lot about magnetic fields.
Fields. I mean, it's amazing. The whole idea of field theory. All of a sudden, you say, "Well, isn't that what the Nobel Prize winners talk about? Field theory all the time. What is a field theory? Isn't that in like 4th year physics or something?
Yeah.
Field theory. So I guess fields are a big thing.
Mm-hmm.
I never even thought about fields that much. The question is it just iron filings that will react to a field? Have you guys ever seen the picture of the frog that's floating in the magnetic field?
No, what's that about?
I don't know. I'll have Jacob look it up. He's over there. somebody had somewhere, I forgot what university it was, made a really strong magnetic field, and they got a frog to float in it, or toad, airborne. I say,
Really?
well,
How
some
did they
things
do
are,
that, Jake?
well,
Did
check
they
it,
feed
check,
it like iron shavings or
here,
something?
set this over the
Right.
way.
Is
I'm
it
gonna
like the
show you
fish
guys
that they
something.
put like sinkers into?
Yeah, I want to show you guys something. Got some grapes. Don't be swinging. By the way, I got a real expensive little spinner, fishing line spinner. You know, one's got ball bearings in it.
Oh yeah. Those are nice.
Really, really loose. Yeah, I'll bring that on over here. And for my, thank you. Got grapes. Just a household grape, right? Is it are grapes magnetic?
No.
You wouldn't think so.
I would think so, because they're not lodestone or iron filings,
Right,
right?
yeah.
Right. There's no iron in them that I'm aware of.
I've got this is this little hook we use in the studio all the time. So this has nothing to do with anything. It's just to get those boogers in there you can't get. But we got a magnet on the end of it there. So I don't know. And there's just a plastic drinking straw, and you can do this at home. Is it moving? Come on, don't fail me now. Everybody's watching. It was working today. What did we do wrong, Cody? Good.
Well, Jake, what would make it move? Why?
Uh-huh. Oh, it's coming towards it, isn't it?
It's coming toward. Yeah.
Isn't it?
It looks like it.
Yeah, it is. It's ever so slightly magnetic. Once you get it stopped swinging, it will pivot around.
But why is it magnetic, Jake?
Why is the iron magnetic?
Well, because of the domains, but you're not dealing with iron. You're dealing with a grape. Is there that much iron in a grape?
There's not much iron in there, but there are atoms and molecules. There are atoms in there, and even everything is magnetic. It just depends on how strong the field is. Oh, am I doing something wrong?
Really? Yeah, you're making it move, Jake.
Are you touching it?
No.
He wasn't
No.
touching
You
it.
weren't touching it.
No, he's not touching it.
Okay. Okay.
So you're
Oh,
telling me
look,
that
it is. It is. It's
it
moving.
is moving. Oh
It's repelling.
yeah, it's definitely moving, Jake.
Well, this is just messing up everything. Look at what Blazer. We're gonna have to hire this guy.
Yeah.
Water is a
points for Blazer.
polar molecule. Isn't that a son of a gun?
But Jake,
Yeah.
again, my question to you is why? Why is the grape able to move like that?
Well, fields will respond to each other, either attract or repel, right? You know this, right?
Right. Yeah.
Yeah, and every atom and molecule in that grape has electrons moving, and you know when electrons move, they create a field,
Okay.
Yeah.
right? So I don't know what it is about the structure of grapes, but there's enough of a field congestion there, strong enough to be repelled by this particular magnet. And if Jacob ever finds it, and I don't know if he will or not, you go online, you'll see a picture of it. They've got a big electromagnet, and there's a frog in there like he's in zero gravity.
Huh.
Wow.
Live frog.
Live frog.
Oh, wow.
There he is. Look at there. Live frog. Going, what did I drink? Man, I'm floating. He's in a
Wow.
magnetic field. I don't know. Had you never seen that before? Yeah, everything will has a field around it if it's got electrons in it. Yeah. And I
That's
don't
so
know. I didn't
amazing.
study enough physics. Majored in it, and I don't know. We were about 40 years behind everything. When
Blazer
I
says that the magnet was so strong that it was enough to suspend the
the
water,
water.
molecules
Yeah.
in the frog.
Anything with a congested. My physics professor called it a congested field, where you get a field that's, dense, right? A congested field. You can it won't be paramagnetic. I guess they call it paramagnetic.
Okay.
And like liquid oxygen does the same thing. Liquid oxygen will react to a magnet too, because of the slight magnetic field, the slight field around it.
Mm-hmm.
But the idea to get across, I think, is that there are these things called fields
Yeah.
around. When electrons move, especially, there are fields. Really?
I believe it.
Okay. We saw the Faraday picture, didn't we? Hey, I
Scott,
want to talk.
Scott, quick question, Scott. Have
Yeah.
you ever seen this done with a grape before?
Not with a grape.
No, me
This is
either.
wonderful.
Yeah.
Good job, Scott.
Hey,
Points for
Blazer,
Jake.
Blazer, have you seen it with a grape before? I don't know.
30 seconds to respond.
Oh, 30-second response. That's right.
Close enough.
Is he on the moon too? It's got to go up to the moon and back before Blazer can respond. But that's all right.
Oh, wow. That was
Okay.
quick.
Thank you, buddy. I wanted you to make. You're sitting here watching. Hey, I saw a grape move with a magnet. Yeah, these guys are
Now
doing
you have.
witchcraft. Yeah, let's set that over there. We'll do something. Well, let's do something else. Hey, a little side thing. I like to go off on side journeys. I need to get sip some water here. Hey, Blazer, we're going to get you the address of the studio. We're going to get you here sometime or get him online.
It's going to be hard from where he is.
Where is he?
I've never seen it done with magnets. I've seen it done with static electricity stuff all the time,
Yeah.
like pulling a 2x4 around, stuff like that.
Oh, yeah. Well, we do that with static electricity. Yeah, we're fine.
I've never seen it with magnetic.
Okay. So there's a long copper tube somewhere. You
He's
see
in
it over there?
Maryland.
Over there by the post.
Oh, yeah.
There's a long copper tube. Yeah, he's going to go over and get it. I know you've seen this with the copper tube and a magnet.
Mhm.
It's got some.
Yeah. And you got the magnets there, do you?
See, Jake, you got more than 2 weapons in here. You hit somebody with
this
this, they're
one.
not going to come back.
This one is cooler.
Does that one do better?
Well, I mean, that one's faster.
Okay.
But you can see.
Okay. But the whole idea is there's a copper tube, right? That's heavy walled copper pipe. You see how thick the walls are on that sucker?
Oh yeah.
Yeah, that is.
And I've got a fairly strong magnet here, and it will just fit inside there. So I'm going to hold that pipe. I don't know how we're going to do this. I'm going to hold it right about here. How are you going to get there and drop that magnet in through there?
You can move to the side, Jake.
He's 6'1".
Okay, he can do it. He can reach it. Look at those big ape-like arms. He's all right.
Just drop right now.
In just a second.
Okay.
Now he's just going to drop that magnet down in that tube. It's a hollow tube. Here we go. You ready?
Yeah.
So wait, how long is this tube, Jake?
What is that? Is that 4 feet?
Looks right about right, yeah.
About a 4-foot piece of pipe, but it's copper, a good
Okay.
conductor of electric current.
I was trying to figure out how fast it should fall down there.
How fast
If
should
you
that
just
fall
fell.
down there? Within a second or two, wouldn't you think? 9.8
Oh, yeah.
meters per second.
Yeah, that's what I would think.
So 9.8 meters that's about 10 meters. Let's say 10 meters. Yeah, that's not very far. Yeah,
Watch out.
yeah.
Mm,
It should fall down just in a fraction of a second.
I mean,
Right.
I'm
Yep.
dropping it, so-
Okay, drop
Okay,
it in
ready?
there. Here we go.
3, 2, 1.
Hello. Hello.
Are you messing with that?
And did you actually drop it?
Oh no, it's right here in my hand.
Okay.
Well, what's going on?
Oh,
Did you see it come out?
there it is.
Did you see
Yeah,
it?
there it is.
How long was that?
Probably like 15,
10
20 seconds.
seconds. Yeah, at least.
10 seconds to drop through there. Here, try this little one.
Okay.
Here's a little magnet. There we go. I'll hold it here.
Yep.
This copper pipe, magnet falling through there. Did you let it go?
Yeah.
It should have hit a long time ago.
It should only take a half a second to fall.
Right. That's
Whoa,
exactly right.
whoa, we cracked
We
it.
cracked it.
Uh-oh.
Explosion. Did you see a spark? I saw a spark. That's all right. Well, we learned something. We cracked the little one or the big one?
Probably shouldn't try and separate that with my hands.
Use the magnet separator.
Which one
Magnet separator.
Magnet separator. We need the magnet separator.
Which one broke?
The small one.
A small one. We forgot to move the big one out of the way. Actually, here, you hold that there. Get your finger in there. No, you're not. You're out. Just a little bit more. There you go.
Wait, hold on. There we go. Yeah.
Okay. There we go. Magnet separator. Get that thing.
Got it out. We're good.
There we
got the
go.
small ones.
Boy, it hit that other magnet so hard it cracked this.
Oh, wow.
Yeah, I'll just say that's
That was a
way
second.
out.
That was a secondary demonstration that we didn't intend to do.
But we did it.
We let those. Better get rid of that thing right there. That could take a piece out of your finger.
I know that's how I didn't separate. So I just.
Of course, the question, of course, is
Huh?
Let me see it.
why is that falling so slow?
Yeah,
So
that
how long did
Huh?
that take?
Oh, 10 seconds.
Okay. But if it just fell, it should only taken half a second.
Yeah.
Okay.
and it's in a copper
I
pipe.
actually did the math.
Uh-huh. I know.
Another point.
Muscle Car Parts talking about. Oh, I never met Eddie. Sit down there. Have you ever met Eddie Currents?
I can't say that I have. Maybe he's from the 60s.
Eddie Currents. Yeah, he knows. That guy's been around. Get yourself roller coaster brakes. Yeah, they do. And car parts says copper acts as a conductor. Yeah. Well, whenever a magnetic field it can initiate an electrical current. And when an electrical current forms, it can make a magnetic field.
Mm.
Does that make sense?
Yeah.
That's kind of screwy, isn't it? Now say that out loud for me.
When an electrical current forms, it can make a magnetic field.
Yeah, when an electrical current forms, when electrons go on the move, right, that make a current, that will generate a magnetic field. And likewise, a magnetic field on the move can make electrons move. It's kind of like love me and leave me. You know, magnet can make the electrons move, and the moving electrons can make a magnetic field. Is that true?
I think so.
Yeah. I like this eddy current thing just because there are some currents of electricity made inside the copper, and those generate a magnetic field that is pushing up on that magnet. Yeah.
Yeah. They oppose the magnetic field of the magnet. They're the opposite. So
Yeah. And Kim wants to know about a thin wall tube. What would happen? What do you think?
Do we have a thin wall tube?
We do. And see, that's a good idea. We'll do that when we do this thing, this activity.
Jacob, would it be up there?
Well, of course, I would guess it would be less because there's less current made, less number of electrons. So Kim, we'll go use that idea when we do this thing, the circle of life. Okay.
Jacob, you see it? It's
We're
right on
good.
this edge.
and I don't know if you had a DC power supply, if you could take a wire
Yeah.
and have current going through it and then sprinkle iron filings on that.
Yeah.
You could try.
We'll try it. Right by Jacob. We're going to try it with a thin walled pipe.
Okay.
Bring that over here, young man. Bring that over here. Here comes a thin wall tube.
We're trying to get a magnet too.
Oh, you got to get a magnet.
I got a small one here.
Here you go. Here comes the magnet. Yeah. Here we go. So you can get it off the pipe. So now we've got a thin wall pipe. See the thin wall pipe? We got a thin wall
Oh,
pipe.
shoot, we both got stuff on our hands.
Okay. Here we go. Thin wall pipe.
Here, I'll
Here,
take
lay
this
that
one.
down over here. I'll hold this up here. That's about.
Get the magnet out of the way.
Yeah. I don't know. Will it fit in there?
Yeah, it will.
Okay. You've got a strong magnet, right?
Yeah.
Okay. I'm going to hold it. He's going to drop.
Oh, it slowed pretty good.
Take a bucket.
Oh, thanks.
It slowed down quite a bit, but not as much as the other
I'm
one,
just gonna
right?
have to grab it again.
Yeah.
Did you notice that? Do that again, Beckett. Should have hit now.
So you need to race the magnets.
There.
Oh yeah.
It's about 10
So
times
it
longer.
did fall, but
Right.
not nearly as fast. I mean, what was that?
Should we do a race?
Oh, get on out of here.
That's them.
I know. 2 magnet race. All right, we'll do that. By golly, we're gonna get
Bring back.
when we put this thing together and make an episode of Midnight Science Club, we'll do that. A blazer. That's
Yeah.
pretty cool.
Do you need
Pretty
this
good idea. What is that?
for your hands?
Oh, I got some cheese on my hands there, right?
I did too.
Okay. Hey, bring over that wire jumping thing. Is it? Kim, have you ever taken a microwave oven apart and gotten the magnet out of the thing? You ever done that? I was asking. Have you guys ever done that? Taking
No.
taking the magnets out of a microwave oven?
No, I never did that either.
It's really quite amazing.
I'm too cheap.
Well, these are magnets out of a magnetron. Go figure.
Ooh.
In for a microwave oven. I'll get all that on there. Hold that battery right there. I don't know. I think there. I got that untangled. Okay. We'll get this all out of the way. So what I've got is see this green wire right here? You got that green wire? There's a green wire. It's a little flimsy wire, a little thin little wire, a little flexible wire. Look, you see how flexible it is? Little thin wire. And I got 2 magnets out of 2 magnetrons. When you take a microwave oven apart, you'll find these circular magnets in there. And the magnetrons, what this is supposed to do, it's really disappointing when you take a microwave oven apart and you say, I paid $400 for this. Because you think the thing that's putting out the microwave would be this hideously big.
That's how I visualize it.
You visualize it,
Yes.
I don't know
Yeah.
we'll have to find it. We'll
Yeah,
get
you
it
think
out.
it's a lot more. You think it's a lot more complicated than it is.
It really is. And somewhere on that shelf, we'll get it out. We'll find it. There's a magnetron over there. It looks like a little Christmas tree light. A little fancy. It's about the size of a Christmas tree light bulb. A little bitty one. And it's putting out a wavelength of light, electromagnetic radiation of just the right size, frequency to make water molecules vibrate. That's all it is. It's a little bitty light bulb. It really is. It's not really a bulb, but it's a light emitter like a Christmas tree light. And it throws out a certain frequency of waves. And these magnets are there to focus that so it doesn't go flying everywhere you want it to go. Magnets are focusing those waves. And you say, well, I don't know about that. I don't see, like you did with the other magnet, I don't see any wave action going on. I just see nothing. I don't feel anything. I don't see anything. So we're going to take these wires here, and I've got a little, volt and a half cell, AA battery, right? And I want to run the electricity from a AA battery through this wire. That's not much. You ever done this, Scott?
I've never done it with battery. I've done it with a DC power supply and
DC
get
power
the
supply.
wire. Yeah.
Yeah, I just wanted to, because people don't have a DC supply around, right? Well, why don't you hold your finger on there? That way, if it burns and blows up, it won't hurt me. Okay. So I'm just going to take the tip of this and just touch it on there. You ready?
Mm.
Let's just watch that wire. Are you seeing it move?
It jumps.
Can you see
Yeah.
that wire move? I think our battery's about dead.
Yeah.
Were we getting more than that today?
New battery.
New battery! Cell. That's a cell. It's not a battery.
My bad.
New cell.
Cell.
We save all of our little used batteries, our used cells for this stuff.
Those aren't used.
Oh, those are the new ones?
Those are the new
Don't
ones.
let let the boss find out. We're supposed to use the old batteries. Recycle the old ones. Still got a little juice in them. See if a new one. Oh yeah, well,
Flip that around.
huh? Flip it around.
Yeah, we found.
Oh, look
Oh,
at
there
that.
we
Oh,
go.
there
Yeah,
we
there you
go.
go.
Better contact.
Point for Cody.
Hey, Kenny's here. Whee! Kenny's here. Scott's here. Yay! Whoop, whoop.
Wow.
That's pretty sweet, right?
Yeah.
So why is it moving? And you could have what, fourth graders or third grade or 10-year-olds say, well, what's going on with that wire now, and what changes when we run the electricity through it? How could little electrons make that whole wire move? I don't understand that.
Well, you mentioned the correlation earlier between the magnetic field and the electric current.
Yeah. Well, this would be a good discussion point, wouldn't it? I mean, what's going on? What's making it move?
Yeah.
Wouldn't it? Hope so. Yeah.
Especially if
Don't
you've
cut
shown them that magnets make other magnets move.
Well, make
Right.
other magnets move.
Yeah.
Mhm.
I'm so glad you made a great segue for me. Thank you so very much. That was like I was waiting, and he said, "Yeah, it's really neat." You just to say it's amazing that just that little bit of voltage, could make a big wire move like that. Here, let's get that thing out
Yeah.
of the way, like a thing like that. I want to show you something from our collection now. I told you we got that ball of gold sitting up there that I'd like to pawn, but I can't because try to be a good man. But I got something in the collection that's really sweet. Are you ready for this? This is ready for this. I think Wizard 2 or 3 got it. I don't remember which one. Right here it is. There it is. Oh, Alexander, I'm glad to see you, buddy. Oh, he just mentioned my skeleton. Back the way that I would like to introduce you to Casey Bones. Casey Bones is the skeletal phenomena.
He's excited.
He's excited.
He looks excited.
He looks excited. We've had him around everything. My father's name was Casey, and then I got the Bones, so it's Casey Bones.
Is that a real skeleton, Jake, or is that a fake one?
Nah, I don't. You have to go over and scratch it and sniff. It's a scratch and sniff. It's a bone. It's plastic. That poor thing has been abused so many times, sir. So many ways.
I think I turned into the skeleton one time.
So anyway, when I got this, Don Herbert, when he gave the collection to me, he said, "Jake, this is probably your most precious item in the collection, probably." Guess who made this?
Tesla.
Michael Faraday.
I got it.
Nikola Tesla.
Oh.
Yeah, this is one of his
It's a point for me.
demonstrators for a 3-phase electric motor. It's really sweet. And what amazes me most about it is back when he was doing his work, 100 years ago, the quality of the machining to get that thing, it moves like butter. Those guys machined this stuff with, but I don't know if you can't see it. There are 3. He was trying to demonstrate a 3-phase motor. That means instead of having one electromagnet pushing another electromagnet, I do 3 of them, kind of in order. Like give 3 people pushing somebody, push it, and then the next person pushes, and the next person pushes, to get kind of a synchronous pushing. Can you see the yellow coils in there, and the red, and I guess those are green.
Yes.
Yeah. And so he times that so that this one will come on and give it a push, and then that one, and then that one, and it goes around, and made a very efficient electric motor. I don't know. I just wanted you guys to see it. Kind of go, ooh, ooh.
So-
I didn't hear you go, ooh.
Ooh.
Woo.
So is this magnet in the wheel?
Yeah, there's the center wheel it's made out of iron, and it's got some wires wrapped around it, so it makes an electromagnet, makes a field. There's a little thin wire wrapped around it, and that makes one of the fields.
Oh.
the one that's mobile, right? And then they've got the 3 other fields around here, placed just right. So you know how it is when you push somebody on a swing, you've got to push at the right time. If you push too soon, you interfere with it. And you push too late, you miss them, right? They had to figure out a way to get this field to come on just at the right time. Come on, push. Just like that little wire. We saw a little wire dancing. This is just that same thing, but it's all coiled up and doing a fancy job of it. So she wanted to know how an electric motor worked, and it said, well, it's a magnetic field generating. It's a generated magnetic field pushing. It pushes, just like 2 magnets pushing apart, but they're electromagnets pushing apart, and they just happen to be mounted on a wheel and axle. That's all an electric motor is. It's so simple. Well, it's not simple, but it's not. There's not a secret to it, you know. So I don't know if we want to make a motor. What do you guys think? Is that going too far?
No, I mean, if you are, I'd do an electromagnet first.
Yeah, do electromagnet first.
Yeah, definitely.
Okay.
Just to show them that part, and then that'd lead it right into the motor.
Yeah. Sweet. We got a box. Do we have a box of electromagnets? We have electromagnets. Oh, do we? What's the
Is the
strongest
look of surprise
electromagnetic?
gone off my face yet, Jake?
Huh?
Is the look of surprise gone off my face that you have a box of electromagnets?
I have a box. Where's that box of electromagnets? We have lots of electromagnets. There we go.
Conveniently
Oh,
labeled.
look at that say. What does it say on the outside?
Electromagnet. Does that say beam ray annihilator?
Yeah, it's an electromagnetic beam ray annihilator. Yeah, something like that. We've got all kinds of. Oh, look at this. Now we're talking simple. What do you think?
Looks like a nail with a wire wrapped around it. Oh, here we go.
Here we go. We got a voltage. We got a power supply. Do we have a battery? Or do I have? Oh, here we go. Yeah. Should we go for 9 volts or should
Should I
we
plug this in?
Well, you can in a minute if you want. We've got all kinds of electromagnets. Look at this thing. What in the world is that? Let's start out with a simple one. Simple electromagnet. Can you guys throw me a cell, like a D cell? Ooh. Yeah. Oh, here we go. This is the Scott Capes electromagnet. Right there it is. Very simple but powerful. You guys, did your students make electromagnets, Kenny?
Yeah, definitely. We had such a good time with them.
So what'd you do with them? Anything particular?
Well, we pick up paper clips and that kind of stuff.
Okay. I don't know if this is going to work. See the battery. Touch that on there and see what we get. There you go. See if a 1.5 volt will make this thing work. There we go. Ready? Got it? Well, that's a dud. Oh, there, it's sticking.
There we go.
Yeah, we're getting a little stickage there.
A little stickage.
Now flip it around.
Who knows how powerful that
Oh,
battery
see, it fell off.
is.
There you go. Fell off. We can need more power than that, but yeah, it was working, wasn't it? You got it on there?
We use the lantern batteries, Jake. The lantern batteries.
Oh yeah, that get a little more current.
Yeah.
Okay,
we go.
there you go. You see it? Now
That's
he's gonna
working.
that's working. Now let's
Take it off.
Yeah. Oh yeah, it fell.
Yeah.
Thank you.
Yeah.
Okay, that works. So what? We need better than that. How many wraps of wire do you think that is?
Maybe 30 or 40.
30 or 40 wraps.
Yeah, we did them with like 100.
No, we got to
wraps.
have more wraps, man.
Yep.
The more wraps you do, the
we-
better it works.
Is that what it is?
Yeah.
Here's one
I mean,
right here.
Do you have your students compare that?
Yeah.
Like
Say that
how
again?
many paper clips they can pick up with like 50 wraps?
Yeah.
Oh, is that
definitely,
what
yeah.
you do? Okay, yeah.
Yep.
The more wraps, the more wraps, the better?
Yeah, the more wraps, the better.
Well,
But
this
what makes
one
it
right
better?
here.
Well, you
This
got more
one right
electrons
here.
flying around that nail.
Here's a D cell, still a 1.5 volts, right?
Yeah.
Same thing I had before. That was a 1.5 volts, wasn't it?
Yes.
So
Yeah.
here's a 1.5 volts. And this one, it's been left on all day?
No, you gotta put the alligator clips on.
Oh, you do? Oh, I see. There you go. There's an electromagnet. There's a 1.5 volt, and this has 5,000 wraps of wire.
That's a little bit better.
That's a little bit of better action, wouldn't you say? There's 5,000 wraps of very fine wire inside of here, instead of the ones we had around that thing. Let's see what we've got in here to pick up. Let's see. I'll just try this thing. Here, you hold on to that. Okay.
Blazer said something again.
What is it?
More wraps of thinner make the motor faster, but fewer wraps of thicker
Okay.
is more torque.
Okay, more torque. There's some torque going on here. Okay. Should say Acme on the side, lab assistant. Okay. I like Blazer. I wonder who Blazer is. I don't even want to know. I just want to picture something. I just want to picture Blazer as this amazing.
He said earlier works on motors for elevators.
Yeah, he did say that.
Really?
Yeah.
Wow. He works on motors for elevators. I wonder what happens if he ever makes a mistake. I don't even want to know that. Well, Blazer, where's Blazer, man?
What's the malpractice insurance on that?
Where's
Jake?
that thing there, Blazer? You forgot
Moved
the
to Canada.
man.
That's the insurance. Move to Canada.
No. I mean, if there was an accident.
Oh yeah. So here we go, Blazer. This is for you, Blazer. 5,000 wraps with a 1.5 volt battery. And I've got this holding here. Let's see what it does.
That attaches to yours.
Oh yeah. Put that on there. We gotta hook that in. Okay. We ain't got all day, you know.
I bet.
The people are waiting. They're about to shut us off.
No.
Yeah.
There we
Here
go.
we go.
All right.
Let's see. Stick that up there. I guess there. Oh, that didn't do anything.
Yeah,
I thought you'd go whammy dammy. We'll pull that part. Well, now what? Come on. Look at that. Now you pull. Ready? I'm going to let go with it. Ready?
Yeah.
Watch out. I'm going to let go. Ready? Hey, there you go. He's a strong kid, too. That is amazing. I wonder how much that would pick up.
Quite a bit, I bet.
What do we got around here?
We
Look over there.
Example?
You think that'd pick up an amble?
Uh-huh.
Let's go find out. We got an amble. You go over there and see what you can do. There, put that and you clip that on. And
Okay.
everybody say, in case we have an accident, goodbye, Beckett.
Bye, Becky.
Been nice knowing you, Becca.
Yeah.
Now you're
been a
gonna take that
pleasure.
same electromagnet, right?
Yeah.
But you got to turn. Yeah. Does it stick?
Yeah,
Huh?
turn on.
Oh, okay.
No. Yeah. Go ahead and lift it up a little bit.
Oh, okay. No.
And now lift it up and put the thing on there. The clip.
Oh.
No, lift it off there. Lift it off there. Put the clip on. There you go. He'll get it. I don't talk very well. What does it say on the side there? 55-pound magnet? 55
Yes.
pounds?
Turn around.
Me?
Yeah, rotate the anvil.
Turn the anvil around. What does it say on there?
55.
55. Okay. Well, that magnet, you're on. Will that little D cell with 5,000 wraps pick up that 55-pound anvil? Ta-da!
Oh, my
All right,
God!
now we're talking.
Wow, that's impressive.
Don't mess with a Beckett. Let me tell you. One more time.
One more time.
All right, 50 reps. Let's go, soldier.
Oh, okay.
Okay, there you go. 1, 2. Okay, give that man a hand. Yay.
I think
Yeah.
something that you probably need to point out is that wire's insulated when they wrap it.
Okay, very good point.
So
Yeah, they're kind of.
You're
it
saying-
just has a lacquer on it.
With 2 T's.
Yeah.
So Scott, you're saying it would be better if it's an
No,
insulated wire?
if it doesn't have an insulation on it, it shorts out and you won't get
Oh,
the current
gotcha.
going through all the wire.
Okay. All I need is a road runner and a switch. That's right. Bye, Beckett. Oh yeah, smack yourself in the face with that. That'd be great. Hey, I want to. We're going to come back to this. I suppose we could say to the gal that wrote in, I don't know anything about electricity. It's just electric motors. It is really just two fields pushing against each other. It's a series of fields pushing against each other is all it is, in a circular fashion. It's really not, it's not that complicated. The engineering of it's kind of complicated.
Yeah.
You know, but just to say what's the science that's going on. But there's something I wanted to show you that Mr. Wizard did, and I helped him build it. He did it in 1951, and we redid it again on Nickelodeon in 1980, and we were wrong. We did a little bad bit of science. Well, we didn't know.
Uh-oh.
We didn't know. Would you get your ladder over and you see way up on the top shelf that looks like those two copper boards that are at an angle up there,
yeah.
connected by the black. Do you think you can get that? Well, you guys better
maybe.
back him up. Gonna roll that old library card over there.
I don't know. That's gonna be a stretch.
I'd go up there and get that myself, but that's
We got tall.
that's just a wood library ladder, so it's kind of clumsy. There you go. Is that up there too far? Look at those big long arms. That's amazing. He's doing it. He's
Thought I
doing
broke it
it.
for a
He's
second.
doing it. He's doing it. Sweet.
Yep.
I thought you guys might want to see this. This was on NBC television back in the 50s. This was Mr. Wizard's attempt to explain how electric current works. Okay.
Are we dropping an Oreo down there?
No, we're not putting an Oreo in there, but I've got to get this just right. Okay. That rings the bell. Now, this is supposed to represent a copper wire, right? And I don't have any electrons. You know, metals conduct electric current because their outer shell electrons are more movable. You know, the further you get out, those outer shell electrons are liable to move on you. I don't have a jar of electrons,
Darn.
but I do think we could use marbles.
Yeah.
So if you go up the ladder again and up there on that shelf with all the balls on it,
Uh-huh.
see if you can find some marbles. Just look around up there. We do have marbles up there, don't we?
Yeah, I think we're on the far right.
Far right. We need
Do
marbles.
we need more than one?
I think we need more than one, yeah.
Yeah. We need marbles.
Oh,
You guys,
yeah.
this is our slightly erroneous but well conceived for its period in history. Now this is 75 years ago. Right. This was the science of 75 years ago when we had the Bohr model of the atom, and I don't know, that's called plastic box. Okay.
Oh, there's tape.
Oh, there's tape. Oh, of course. Well, take a break among yourselves. You go to the restroom. It'll be about 20 minutes while he gets this thing unwrapped.
Is that tape? I can't even see. I can't get to
Can't
it.
see it. What kind of? Oh yeah. What kind of wrap is
See,
that?
I can't.
Okay, you're right. You're right. You're right. I'll give you that one. That was one. Take one off of mine. Okay. It's all taped shut.
It's like.
Yeah. Okay.
There we go. Can I
We
get it?
should have done this before we started the thing. Okay. There. While we're doing that,
Can we get it?
Yeah.
older elevators use a series of shunt fields.
Use series and shunt.
Okay, shunt fields. Series and shunt fields. Oh, I got you.
So
Now they
maybe
use
it's like
permanent
shrink
magnets.
wrapped or
Okay.
something.
Yeah, it does, huh?
Well, they just didn't want those marbles to come out of there, did they?
No.
Well, we should have done that. I'm sorry, that's bad preparation on our part today to get the marbles.
How are we to know that they were
Tape
intended?
shut. Well,
to
that's it.
stay in
That's what
there.
we should have done. What do you think is going to happen, Scott, with this?
I really don't have a clue on this one.
Well, how does electric current move through a wire?
Oh,
That is true.
I'm trying. It's really
I'm just trying to figure out with the notches in the.
Yeah.
Blazer
So,
said.
so do electrons run when you get when you have electricity running through a wire?
Mhm.
It's not at the speed of light, but it's very fast.
Right, right.
Yeah, I forgot what they call it, the diamagnetic, whatever it is. There we go. See, that had a child-proof seal on there,
And see,
and it took three grown studio guys to get that darn box of marbles open.
only took two of us.
Okay, only
2.5.
2.5. Now I hope these will work. We might have to find some other ones if they don't. But supposedly, if those were
Okay.
electrons free electrons, or not free, but they're on the outer shells. I don't know if this is
Yeah.
going to work or not. We might have to get bigger balls. This will be something we'll get ready for this when we do this. But I don't even know if I'll do this anymore because it kind of tells the wrong story about. Is there another one out here?
No, there's not one right there.
Oh, there's not one there.
One
Oh,
is-
oh, not one marble. There's a slot,
Yeah.
but not a marble. Okay. Now, supposedly, what's supposed to happen with this demonstration of old school, what did you just? You scared me to death. I thought I was dying there. Oh, that's the big that's the big one. That's big. We had a great big electromagnet there. That if I could get electrons to move through a wire, suppose this is the electron I'm trying to get to move. I want to get this electric current to go through the wire. Does this one go by itself all the way to the end of the wire? Is that what happens in an electric current? That electrons travel like this to the wire, and they shoot out the other end.
No.
If I put this electron in one end of a wire, will it come popping out the other end like water?
No.
I don't know if this is going to work or not. It worked,
Oh my
Mr.
gosh.
Wizard. It worked. Oh,
Didn't ring the bell though.
it didn't ring the bell. I have to grease the bell. It's supposed to go ding. Ding, ding, ding.
Ding.
Now the electron we got moving is still there, right?
Mhm.
So if I would get an electromagnet, or if I got a magnetic field to get a electron moving, which what we do with generators, motors, if I could get this electron moving down at this end of the wire, what does it do to the other electrons?
Pushes them down the line.
Down the line.
We got
That's
two.
right. Yeah, a little lightning bolt there. Yeah. Well, this is not a very good, accurate description of electric current, because we know electricity travels near the speed of light, right? It's fast, and these guys can't move that fast through the wire. But the field around the outside, see, we had electromagnet. We had a wire, right, that had a field around it.
Yes.
It's the field that gets pushed around the outside of the wire, even though we can't see it. When that electron moves, it makes the field out here move. And that field can get going really fast. Kind of like in the ocean, there's a tsunami. They say a tsunami's traveling 200 miles an hour across the Pacific Ocean. Is the water traveling that fast? I mean, that bucket of water isn't going 200 miles an hour. What's happening? What's moving 200 miles an hour?
The wind.
Not the wind. Close.
The air.
No. Something's moving fast. They say that tsunami's headed right towards Hawaii. Look out, here it comes. The wave.
Oh.
Yeah. The energy in the wave.
The energy in the wave is going, and it's not, the water itself will move a little bit, right? It'll go, splashy, splashy, it goes up and down. But that wave could go just tearing across the ocean. And if you give it a push just at the right moment, you can make it even go faster, right? If it builds on itself. It's the field that moves. Not the electrons. They call this electron drift. It drifts and they'll go back and they'll go forth and something like that. But the magnetic field that's around these wires travels at extremely high speeds, and that's what travels. And scientists study the field. They call it field theory. All kinds of fields and the interactions of fields. And the first time field theory was explained to me by Leon Lederman, he had a Nobel Prize in physics, and he said, it was at a presentation at the Hall of Science in Chicago, Museum of Science. He said, the human body is made of light. The field that's generated as the light moves, and even the electrons really don't exist. They're just knots of light you know, and they feel like they're there because they're knotted, but they're not even there. And that the entire mass of your body, if you took out all the space of your body, would fit on the printed dot on a printed page of ink. The ink on one period on a printed page is the volume of all the solid stuff in your body. If we just squeezed it down and got rid of all the space inside of the atoms that you're made of. So it's a magnetic field. It's what we're made out of, fields. And I'm going, what are you talking about? I still don't understand that. Magnetic fields. So this demonstration, even though I used it on Jake's attic and Mr. Wizard used it on, I don't know, 30 years on, he was on television 50 years. He used this to explain it. He said, you know, we let young kids believe it was electrons moving through the wire that does all the work, and it's really not. It's the field that this moving electrons stimulate. It's doing all the electrical work. I don't know. I like the marbles better. Tell you the truth.
Yeah.
I like the marbles. I feel
I
comfortable.
think it's a good introduction. I'm just trying to think of how you could do it as a field.
Well, that's what I'm saying. You can't see the darn field. You
Yeah.
got to put iron filings in it and everything like that. So anyway, we'll still use this thing because it does demonstrate that current moves through a wire, but it's going around the outside of it. But for our purposes, we just have to think of it like it's plumbing, because there's not a whole lot we can do to control fields easily, I guess. I don't know. Anyway, I thought it would be good to see this thing.
Yeah.
You know.
And is that how you do it for your students? You talk about it in terms of like use the water analogy.
Yeah.
Well, you're talking about electrical current. And,
Yeah.
Well, here's the problem. Here's the you can't. It's almost like I can't tell you the whole truth at the very beginning because it'll mess your head up. You got to get.
Yeah.
You tell. It's like using metaphors and things. You got to get them in the. Oh, by the way, you know, it's not really the electrons they are moving. You know, but it's the field. All the energy, all the hard work is being done by that field that's out there. And of course, say, what field are you talking about? And so, of course, what you do is you have them go out and stand under a high power line at night and swing a fluorescent light bulb over their head, which is kind of unsafe. Did you ever do that?
No, I've never done that, Jake.
Well, you get a fluorescent light bulb, if they still make them, I guess. On a dark night, if you get close to a high line, it doesn't have to be very close. You tie it on a string safely, get some goggles on, and you swirl that fluorescent tube around over your head. It'll light up.
Wow.
You say, well, where's all that energy coming from?
From the field.
Yeah, it's a field around those tension lines up there 50 feet above your head. You're going, really? Yeah, you're walking through that field right now. I don't know. I don't know how far we should go with fields, to tell you the truth. But anyway, what do you think?
Looks good to me.
Let's move on to something else, and then we'll. Oh, I got to show you guys something while you're moving all this stuff out of here. You know, we always try to get things better and better all the time. We had a discovery this week that, you know, I'm always trying to, you know, all the stuff we used to do with candles and Faraday's chemical history of a candle, right? And I don't know, for years we've made the little flame jump down on the candle. You know, we've done the candle jump thing, right? And they say Faraday could get it to jump 6 inches to a foot. And maybe I've been a 3-inch or 4-inch guy my whole life. I've never paid a whole lot of attention to it. But by golly.
I think it depends on what the candle's made of.
It depends on what the candle's made of, for sure. And I didn't think it was that big a deal, but it really is. And I'm going to let that burn just for a second to build up a little pool of wax there. This candle is a regular candle, but it's covered with lycopodium dust. I've been doing the lycopodium thing, and it got the wax all dirty with soot. So I got dirty wax. And you can tell how dirty it is because that flame is not bright yellow. It's kind of orangey, isn't it?
Mm-hmm.
It's not as hot. So I've got a lot of copper in there. And I want you to notice the difference if I can pull this off. Then I'll have Becca try it. Get up over here close to me. Because well, we'll see how far I can make it jump. That's not bad, is it?
No.
Was that about 3 inches?
Probably.
Yeah, something like
Something
that.
like that. So we'll try this. Instead of me blowing it out and disturbing the air, I'll smother it. Aha. A lot higher, right? You see that? That's almost 5 inches right there. Let me try that again. Oh, that's good. Anyway, you can practice this, Beckett, because you've got to get up to 7 or 8 inches.
All right.
With your own methodology. But just having a dirty candle made all the difference in the world this week. We found out. Oh, that's good. That's 4 inches right there. But this afternoon, we were up about that high. I think it's because we got the air conditioning on. We get a long stream of smoke. And did you ever do this, Kenny, in the classroom?
No.
I would do this when the kids were acting up and nothing to do. They'd do this for hours. Just sit there like idiots going, fire, caveman, ugh.
Yeah.
It was great. Smother the flame. Bring it up. Oh, that was a good one. Smother that flame. Pull it up. There it was. Oh yeah, that's. See, I was approaching 6 inches on that thing.
Yeah.
Aren't you proud of me?
Yeah.
I mean, I'm getting better all the time. I'm like wine or cheese, you know.
Yeah.
I age just fine. We get that too. You ever do this, Scott?
Yeah.
Okay.
Actually, I think we did it. We did it on the Grand Illuminator one time.
Oh yeah. Well, we never. I just never got past about 2 inches thing, and then now we're realizing it's the cleanliness of the flame is a major factor.
But like I said, if your wax wasn't as pure to start with, like
That's right.
in olden times.
In olden times, a little lard in there, a little tallow.
Yeah.
Maybe I'll get some tallow.
Whale oil.
Whale oil.
Yeah.
Lard. I used to have a girlfriend named Lard. She's a big old gal, but we liked her.
Look what Blazer said. He said something about the high voltage power lines.
Oh yeah. Oh yeah. Yeah. Well, we'll do some of that here in a moment. We're going to do some stuff. We got about 10 to 15.
You should read it, Jake. Scott and Ken can't see that.
Okay. Some years ago, an artist did an installation with hundreds of fluorescent bulbs in a field below a high voltage line. You should see the lights change as people walked between them. That's cool. Thank you for sharing that, Blazer. We'll do that. Hundreds of fluorescent bulbs in a field of high voltage lines.
That'd be cool if we did that.
You want to do that? You want to do that?
Maybe.
Well, I don't know. Let's see what's else on our list. We could talk all night about. Should we move up to transformers? I want to do this one for Blazer. I want to find something he hasn't seen before. It's going to be hard to do. So we're going to move this stuff on. Why don't you bring those high voltage transformers over here? Want to do that? Where are those things? Let's get that set up. One moment.
Are these just robots in disguise, Jake?
Huh?
Are these
No.
robots in disguise?
Not Autobots.
Autobots? I don't know what he's talking about.
He's talking about like the movie Transformers.
Oh, that movie? I don't know. I'm old Transformer. Get out of here. I don't know any of this stuff. Oh yeah. Set that down here.
This would be a small robot.
Oh, a small robot. Yeah. And we'll leave that off, but just you can unplug
unplug
that one down there, and we'll let's see, the power is on. When that goes over there, the power is on. When it's over this way, the power is off, okay?
Okay.
So if I start screaming and yelling,
Yeah.
would you please flip that switch?
Sure.
Okay.
You
Don't
wanna
plug that
you
in.
wanna
No,
do-
no,
don't
don't
wanna
plug that in
do
now.
not. No.
Here you go, Cody, I'll give you that. Okay. So I've got this here. Yes. There we go. I have my foil covered finger.
It's always a good thing to have.
So I think later on, maybe the next series after we talk about magnetism and electricity is a transformer. And would it be fair to say that a transformer uses one magnetic field to generate current in another coil of wire? I guess the magnetic field around one coil of wire will generate current in a nearby second coil of wire.
Yeah.
Would that make sense?
Yeah.
After seeing, said, hey, we were generating magnetism here, and we were doing it over here. What if we put two of those together? You know?
Yeah.
And what would happen? Because we saw that the more wraps you had, the stronger the magnetic field, or the more concentrated it was. And the less magnetic wraps you had, the less of a field you'd have, right?
Mm-hmm.
So if I wanted to get a really strong field, I could have a small number of coils close to a great big number of coils. And this would get a lot more electrons moving over here. So I'd have more wraps of wire.
Mm-hmm.
So we've already seen what it does. What if I had a few guys doing this, and then I had a wire coil over here with 10,000 times more wraps?
That'd be a lot.
That'd be a lot. So you see what it says right up here? Input voltage is what? What's that right there? Primary.
120.
120. And what's the secondary, the output?
1500. No.
No.
15,000.
Somehow the coils of wire in here are arranged so that the magnetic field around the 120 volt coil will stimulate electrons to move in 50. I don't know how many wraps that would be. Thousands, right?
Yeah.
Yeah. Supposedly we're going to put 110 volts through here, and we're going to get how many volts out? 15,000. So plug that in and see if that happens.
Yeah.
Plug it in. Are you ready? Now right below it, flip the switch over.
Now?
Yep. Whee, doggies. So there goes a Jacob's ladder, by the way, named after Jacob. What a wonderful name is Jacob, right? And of course, we're making a little lightning bolt. You can put that switch off, right? Don't want to touch that. That's 15,000 volts of wire, of electricity going across those two wires. And it wasn't that much electricity going in, was it?
No.
No. How does that happen? Well, they call it a transformer. I'm transforming the voltage, you know, because I had a fewer number of coils at 110 volts next to many thousands of coils of wire that generated that 15,000 volts of electricity. But one thing somebody told me once, does it say what it is? It says on here. What's that HZ? See right there? What is
60.
60. What's that mean?
60 hertz.
Do you guys know what HZ means?
Yeah.
Hertz. What's a
Cycles
hertz?
per second.
Another
So-
point.
What is that? Oh, the electrons are not moving. What are they doing? Yeah. The field, he's right. He's out. The field is moving. That's right. What we saw was superheated air. Absolutely. Yeah, you're right. It's superheated air. Yeah, we're going to do that, Kim. I told you we were going to do it. Kim's got a suggestion. We do something to show the AC, which we're going to move to before we run out of steam here. Yeah. 60 cycles. Well, what does 60 cycles mean?
That's really funny. Look what he said.
Yeah.
What do you say?
He said
It
it's
depends-
how bad
It hurts when you get shocked. Right? Now I've done this thing tons of time. We're going to run out of time, so we're going to continue this down the road because I talked too much tonight as usual. But I talked to some really good people, You know, that was great. I appreciate it. But this one really impressed me when I saw this for the first time. I mean, it takes a lot for an old wizard to be impressed. But it says 60 cycles a second. And that means back at the headquarters where they're generating electricity, something's spinning 60 times a second, generating a pulse, a field. We call it field. It's making the electrons move, even though we know it's the field that's moving 60 times a second. It's going one direction and then the other. It goes up and back, up, and they call that alternating current. Direct current just goes, alternating current goes wee, back and forth, wee. I've never seen alternating current. I can't tell the difference between, by looking at it, direct and alternating current. I suppose you could feel the difference. You stuck your hand in there.
I bet you probably could.
Yeah. Well, we're going to demonstrate 60 cycles a second. Have you ever done this, Kim? Yes, Kim has. How about a Blazer? Have you ever seen 60 cycles per second in action? Give him some time to talk about that. How bad it hurts when you get shocked.
Probably pretty bad. I would estimate it'd be.
It's not the volts that kill you, it's the amps.
Is that what it is? Yes. Hey, what do you tell kids the difference between volts and amps?
Thousands of times.
They say, what's a volt? What's an amp? What do you tell them?
Volts potential energy, amps is the movement. When I tell them it's the movement of electric charge, but it's actually the movement of the electric field.
See, the way I used to do it was kind of wrong because we're talking about the plumbing side, the electrons moving.
Yeah.
We would say amps tells you how many electrons are moving, and volts is how hard are they coming. Increase the voltage, you're getting them irritated and they're coming harder. And
in electrochemistry, you still talk about it like that.
Yeah, and that's the way
you look at how many electrons are being
voltage,
deposited.
electric pressure, thousands of times. Yeah, you got it. Okay, so here's a piece of construction paper, and I want to try to pass the spark. I want to try to keep up the spark. I want to try to pass this through in 1 second.
Okay.
Just like 1001. Would that be a second?
Yeah.
Like if I want to get that spark, 1001. That's about a second's worth, wouldn't it be?
Yeah.
Close enough. 1001. Okay, now we're going to turn on the spark. And it's been nice knowing you if I kill myself here. 1001. Here, ready? 1001. Okay, shut it off. What do you see right there?
Looks like we got some dots.
Let's hold them up to the light. What do you see?
We got some holes.
Now we'll try to get a picture of this. But right
How
now,
many holes?
Yeah. Let's see, he's going to try to get this so you can see it on the camera. We'll see what we can do here.
Yeah.
I'm going to guess it's somewhere between 55 and 65.
Can you see him? I'll see if
Like
it comes
right
up
between that?
Somewhere in there.
I don't know if we're going to be able
I'll
to
have to
get it.
see it on the.
Can't really.
We're going to try so you can see it. It burns 60 holes in a second. This is like machine gun fire.
Oh, there you go. There you go. You
Wow.
can see it.
You see them?
Yep.
Not all of them.
That's
but
for
can
you,
see it.
Blazer.
You see a bunch.
Yeah.
And Jake still has all of his fingers.
And I still have my fingers.
Yeah.
But that's 60 cycles a second in action. It's 60 times it's going back and forth.
Huh.
Isn't that amazing? Have you ever seen that before, Scott?
Not that way, no, huh?
All right,
I've
then we
never
did
seen it.
something. I've done that thing 4 times. That's the way we do it. Listen, we're done talking. We could go on forever.
We
2
could.
hours. Yeah, we go on forever. I want to thank you all for coming by. We kept track of all of your comments, and we're going to include those. So we're going to turn these into teaching segments. And you guys kind of guided my thinking, which I do appreciate it. And if I do make $1 million doing this, you guys call back and say, with your hand up, I go, Blazer and
Muscle car.
and Muscle
Pat.
Car Man, they're gonna come back. Hey, Jake, remember us? Yeah, okay. We'll take care of you.
Shout out to Ken too.
And Kim.
Hey, we got Muscle Car happy. That was impressive. Awesome. She sat here for 2 hours, man. Listen, and we got to the thing with the machine gun fire. That's pretty cool. Yeah, we did all right tonight. That's great.
I don't
Thank
know
you
if
all
I try that with my Jacob's ladder.
Yeah, you got Jake. You got one.
Yeah, mine's a little bigger.
You have pictures of it or something?
No, it's up in my barn loft.
You have a big one in your barn loft?
Yeah.
That you run, okay, well, sometime we'll see that.
Look at what.
Yeah, I'll
Kim's
have to
got.
get it out.
Okay. Acrylic tube, a slot for paper. Oh. Well, very good, Kim. Kim suggests we do it, protect the kids so kids could come up and do it without frying their knuckles.
Keep their fingers. Win-win.
Yeah. I thought maybe I'd get a big sheet of flash paper and give it to Scott to try. What'd you do? You did great. Thank you, ladies and gentlemen, for being here with us tonight. We got a lot of good ideas. We'll turn this into some good science education videos, and it's great. Do we have any other news to share with the folks?
If they like this, let's subscribe to our channel.
Yes, please subscribe.
Yeah, please subscribe.
Like the-
everybody
like
know.
and subscribe.
Bring
Yeah.
some friends.
Yes.
Yeah, subscribe. So we can
Share it
get-
with your friends.
Share with your friends. Do you have friends?
No.
Well, there you go. This was fun. Thank you for being here with us, and hope you have a good life and everything's good to you. It's a beautiful world.
That's the wizard blessing.
The wizard blessing. Let's see if they know what the wizard, our motto is here at Faraday.
Oh yes. They better be pretty good at Latin for this one.
We have two inspirational messages here, ladies and gentlemen. 2,774 is a number I keep handy. There it is, 2,774. That's a number we all know. That's the number of times Edison failed with the light bulb. All right, so there you go.
And then.
You're supposed to go, ah.
Oh.
Ah.
And for the true wizards and people who are like Kim Arnold and others, are ornery guys who love to do science tricks and things, this is our motto. Center
What
copy.
is?
Always arrested, never convicted. Never mind.
I thought it was funny.
I thought it was funny and
Yeah.
on everything
Yeah.
on in Latin. Okay.
It is.
so much-
It is funnier in Latin.
Is it? Okay. Well, that's what I'm saying. Well, thank you, gentlemen, for coming.
Yeah. Well,
And
thanks for
sharing
having
knowledge.
us.
Yeah,
Well,
Jake,
share
thank you so
knowledge.
much for having us.
No, it's fun. We're gonna make this thing grow significantly. I think there's a big need. There's
It's nice
a
to
big
meet
need
you,
for
Ken.
it.
Yeah, Scott, the same here. I love your insight. You know, I don't have the physics background that you do, so it was nice to be able to hear what you had to say and to play off that. So I appreciate it.
Yeah. Problem is, my physics background is way in the background. You got to think about it. It's way back there. You know?
I guess that's the thing, because chemistry hasn't changed all that much
That really hasn't.
as far as theory and stuff.
Well,
I
the
mean, a
basic,
little bit with fractals and stuff like
yeah,
that.
but
but
that's just different recipes. Still a chocolate chip
yeah.
cookie.
Whereas
you know?
physics, I mean,
Exactly.
all the stuff I learned in college, it's half of it's not applicable anymore.
Well, it's still there, but it's
Yeah.
too slow, and things are moving fast, but not really. Well, it's just like those four guys that just went up in space, and they come back dumbfounded. They're trying to describe it, you know. They're going, It's just like they were coming down from some drug trip or something. They're going, the world's beautiful.
Yeah,
You
that
know?
is
I
what
mean,
they
they were
said.
so inspired that it was like,
Yeah.
what do you got to say, smart folks? And they go, the world's beautiful. Blazer, thanks a lot for coming by.
Yeah.
And Muscle Car Parts and Tim and everybody else. Thanks for sharing.
Yeah.
I guess it's time for us to go to Walt's and get a cheeseburger.
Buenos noches.
Buenos noches.